now start exploring the methods of inferential statistics. The major activities of inferential statistics involve using sample data to estimate a population parameters such as population proportion, population mean, population standard deviation, and using sample data to make a hypothesis or claim about population parameters. In this video, we'll learn how to construct and interpret the confidence interval estimate of the population proportion. We will be able to identify the requirements for this procedure and will develop the ability to determine the sample size needed to estimate a population proportion. If you want to estimate a population proportion with a single value, the best estimate is the sample proportion p hat. Because a sample proportion consists of a single value that is equivalent to a point on the line, it is also called a point estimate. We call a sample proportion p hat an unbiased estimator of the population proportion p because it's the most consistent of the estimators that could be used and that targets the value of the corresponding population parameter, in this case, population proportion. Let's first go over some important definitions. A confidence interval, also called interval estimate, is a range of values used to estimate the true value of population parameter. The confidence level, also called degree of confidence or confidence coefficient, is the probability of 1 minus alpha, such as 0.95 or 95%, that the confidence interval actually does contain the population parameter, assuming that the estimation process is repeated a large number of times. Alpha refers to the likelihood that the true proportion parameter lies outside the confidence interval. Basically, it's the probability of making the wrong decision. A critical value is the number on the borderline separating the sample statistics that are significant high or significant low from those that are not significant. For confidence interval estimate of population proportion, we will use z-statistic. The margin of error, also called the maximum error of estimate, is the difference between the sample proportion p hat and the population proportion p, and it's found by the formula E equal z of alpha over 2 times the square root of p hat times q hat divided by n, where p hat is the sample proportion and q hat is the complement of the sample proportion found by 1 minus p hat. The requirements to build the confidence interval for estimating the population proportion p: the sample needs to be a simple random sample. The conditions for binomial distributions must be satisfied. There is a fixed number of trials. The trials are independent. There are two categories of outcomes, usually referred to success and failures, and the probabilities remain constant for each trial. And there are at least 5 successes and at least 5 failures. Let's go over the steps for constructing the confidence interval manually, and then I'll show you how to build the confidence interval using StatCrunch and TI-84 graphing calculator. First, no matter what technology we use, we need to verify that the requirements are satisfied. We will use StatCrunch or TI-84 graphing calculator or table A2 to find the critical value z alpha over 2. Next step, we will evaluate the margin of error using the formula z of alpha over 2 times the square root of p hat times q hat divided by n. Then, using the value of the calculated margin of error E, we will find the confidence interval limits and write it in one of the 3 forms. Either p hat minus E to p hat plus E, or we can write it as interval. Remember how we wrote interval in algebra class? For example, interval for the values between -3 and 5, we would write as -3, 5. Or we can write the confidence interval estimate of population proportion as p hat plus or minus the margin of error E. And finally, round the resulting confidence interval limits to 3 significant digits. Let's now do the example. Touch therapists participated in 280 trials of their ability to sense a human energy field. In each trial, a touch therapist was asked to identify which hand was just below the hand of Emily Rosa. Among the 280 trials, 44% resulted in correct identifications. We will construct a 95% confidence interval estimate of the population proportion P, and based on the results, we'll answer the question, what can we conclude about the effectiveness of touch therapy? Basically, we are conducting a study about the effectiveness of the touch therapy based on a sample of 280 trials. First, we need to verify that the requirements are satisfied. The sample is a simple random sample. Yes. We assume that it is a simple random sample, and then the study was conducted with the sound methods. Let's check if the conditions for the binomial distribution are satisfied. There are a fixed number of trials. Yes, there are 280 trials. The trials are independent. Yes, the ability of one touch therapist does not depend on the ability of the other touch therapist. There are 2 categories of outcomes. Yes, the touch therapist can either sense the correct hand or cannot sense the correct hand. The probabilities of success remain constant for each trial. Yes, each therapist can sense the right hand. The next step is to find z of alpha over 2. To find the critical value, we will use the confidence level of 95%. Because it's a normal distribution, we will draw a diagram. 95% or 0.95 area will be right here in the middle. That will leave us with 5% or 0.05 for the 2 tails. Therefore, each tail is 2.5% or 0.025. We can also find it by subtracting 0.95 from 1 and dividing by 2 because there are 2 tails. So we are looking for the critical value z of alpha over 2 that separates 0.025 area on the right. If you want to use table A2, we will need to find the area to the left of the critical value because remember, table A2 shows areas only to the left of the z-score. The area to the left is 1 minus 0.025 or 0.975. The area of 0.975 will be in the positive z-scores part. The areas are located in the middle of the table. Once we found the area 0.975, then we go to the left for the first 2 digits of the z-score, 1.9, and then go up for the second digit. The z-score that separates 0.975 on the left is 1.96. If you use StatCrunch to find z-score, we use stat, calculator, normal. Then we can just specify the direction of the probability to the right. The area to the right of z-score is 0.025, corresponds to the z-score of 1.96. Critical value that separates 0.025 area on the right is 1.96. Next step is to evaluate the margin of error using the formula E equal z of alpha over 2 times the square root of p hat times q hat divided by n. Let's identify these values. P hat is the sample proportion, which is in this case 0.44, 44% of correct identifications. Q hat is 1 minus p hat is 1 minus 0.44, 0.56, and n, total number of trials, is 280. Now that we have all the values, we can substitute them in the formula. Z of alpha over 2 is 1.96 times the square root of 0.44 times 0.56 divided by n, 280, equal, I'm going to use Desmos Scientific Calculator. Go to desmos.com, Math Tools, click on Scientific Calculator, enter the values in the formula 1.96 times square root of 0.44 times 0.56, put it in the parentheses because we need to divide this product by 280, enter, equal to 0.05814, rounded to 3 significant digits, 0.0581. Now let's write the confidence interval limits. Population proportion is within the limits p hat minus e to p hat plus e. P hat is 0.44 minus e is 0.058. 2.44 plus 0.058, 0.382 to 0.498. We can also write the confidence interval as 0.382 to 0.498. There is the third way to write the confidence interval p hat plus or minus e. We will look at it a little bit later. Now, let's answer the question. Based on these results, what can we conclude about the effectiveness of touch therapy? The interval is from 38.2% to 49.8%. It is lower than 50%, so we can conclude that the touch therapy is not effective. Now let's look at how to write the confidence interval in this form. To find p hat from the interval limits, add the lower interval limit and the upper interval limit, maximum plus minimum divided by 2. In this case, we'll add 0.498 plus 0.382 divided by 2 equal 0.44. And to find the margin of error from the confidence interval limits, subtract the lower interval limit from the upper interval limit, maximum minus minimum, divided by 2. 0.498 minus 0.382 divided by 2 equal 0.058, which is the same number that we found using formula. Now let's look at how to find confidence interval limits using StatCrunch. To build confidence interval estimate of population proportion in StatCrunch, go to Stat, Proportion Stats, One Sample. We can build confidence interval with data if we have raw data or with summary. In this case, we have summary, so we're going to click Summary. We will need the number of successes and number of observations. The number of successes can be found by multiplying p hat 0.44 times the total number of observations. The total number of observations was 280, and the sample proportion p hat was 44%. We will use Desmos Scientific Calculator to multiply 280 times 0.44 equal 123. We round this number up to the next whole number, 124. We're not doing hypothesis test for population proportion yet. That will come up in the next topic. Click on the confidence interval for P. Adjust the level of confidence if needed. We are working with 95% of confidence level right now, so we will leave it as 0.95. Method, standard Wald method. compute, the confidence interval limits are 0.384 to 0.501. They are slightly different from what we got by manual calculations, because if we round up the number of successes to 124, would be 0.443, 44.3%, and we used 44%. But this slight difference is fine. I also want to show you how to use TI-84 graphing calculator to build the confidence interval for population proportion. Go to Stat, Tests, go down to 1 proportion Z interval, click Enter, enter the number of successes. 44% of 280 rounded up is 124. Number of total observations, 280. Adjust if needed confidence level. In our case, it's 0.95. Calculate. Confidence interval is 0.385, rounded to 3 significant digits, to 0.501. And again, this difference resulted in rounding, because when we multiply 0.44 by 280, it is 123.2, and we rounded it up to 124. Now let's learn how to determine a sample size needed to construct a confidence interval estimate for population proportion. When we do know sample proportion, then we use the formula z of alpha over 2 squared times p hat times q hat divided by margin of error squared. If we do not know the sample proportion, then we use the following formula: z of alpha over 2 squared times 0.25 divided by margin of error e squared. Where does this 0.25 come from? Well, if we assume that p hat and q hat are 50% each, then 0.5 times 0.5, that's what will give us 0.25. Let's read the following example. If we want to build a confidence interval about the percentage of adults who make online purchases, how many adults must be surveyed in order to be 95% confident that the sample percentage is an error by no more than 3 percentage points? The first part, we will assume that a recent poll showed that 80% of adults make online purchases. So we do know p hat is 0.8, 80% as a decimal. Therefore, q hat would be 1 minus p hat, 0.2. Now we need to find z of alpha over 2. We already found that z of alpha over 2 for the confidence level of 95% was 1.96. So we are going to use this value. If you missed it, you can go back to the beginning of this video and watch how we found this critical value z alpha over 2. I'm going to use the formula with the p hat known, z of alpha over 2 squared times p hat times q hat divided by margin of error squared. Margin of error is 3 percentage points, so e is 0.03 as a decimal. 1.96 squared times 0.2 divided by 0.03 squared. We can use either Desmos scientific calculator or graphing calculator or any other calculator that you have available. I'm going to use my TI-84 graphing calculator. Parentheses for the numerator, parentheses for 1.96 because we are going to square it, times 0.8 times 0.2, close parentheses for the numerator, divided by, open parentheses, 0.03, close parentheses, squared, equal to 682.95. Always round up when dealing with the sample size, equal to 683. we need to survey at least 683 people if we want to build 95% confidence interval that the sample percentage is in error by no more than 3 percentage points. Now let's assume that we have no prior information suggesting a possible value of the population proportion. If we do not have a sample proportion value, then we'll use the formula n equals z of alpha over 2 squared times 0.25 divided by e squared. Z of alpha over 2 is 1.96 squared times 0.25 divided by 0.03, the same margin of error, the same 3 percentage points as a decimal, is equal 1067.111. We always round the sample size up to the next whole number, 1068. Do you see? Now the number is higher, because if we don't know the sample proportion, that we need to survey more people. In the next video, we will learn how to estimate a population mean, how to build a confidence interval for population mean using Table A3, StatCrunch, and TI-84 graphing calculator, and how to determine a sample size needed to build a confidence interval for population mean. Stay tuned.